Hello everyone, welcome to College of Technology solution video, and today's chemistry 2016 still, and this is Q5. Now we have propane. Yep, this is entering the organic chemistry. This is for question A. It says that for the thermochemical equation, combustion of propane, remember that alkane, especially we have the example of propane, it always have perfect combustion. What it means is, if you burn an alkane, it will actually perfectly combusted into carbon dioxide and oxygen, and of course with a certain different number of atoms. If you have butane, pentane, it has different number. Now we only ask about the coefficient of A. Okay, so the thing is, we have to list the difference between this. C, in this one, the reactant has 3, H has 8, O has 2A. Okay, in this one, we have C, B, it's only B. O has 2B plus C, right? And then what again? H has 2C. I think that's all. So this is 2B and this is C. Okay, so B is 3 because from product and reactant should be the same about the coefficient. So B is 3, and if C here for H it is 8, so H here the C is 4. So the oxygen here is 2A equals 2B plus C. And now we know that B is 3 and C is 4. So that is 6 plus 4, which is 10. So 2A equals 10. So A is 5. So the answer is third option, right? And for B, it is about stoichiometry, but it is still related to Q5. And it says that calculate the quantity of heat when the propane has the volume of 2.24 liter is burned at standard state. And remember, for the coefficient of standard state, you see at the top there, you see that the coefficient there is molar volume of gas at the standard state is 22.4 liter per mole. So now this is actually a simple question there. Now you see that at question A, it has the value of Q, which is 2219 kilojoule. And now we have a volume of 2.24 liter. Later, we can see that we only calculate the quantity of heat to burn or to combust it, the propane who have the volume of 2.24 liter. Okay, you can see there at the QA it says that 1 mole of propane to be perfectly combusted need 2219 kilojoule. Therefore, for only 2.24 liter, we must find the mole of the propane. To find it, it is volume over 22.4. Remember that this is a constant. It is heat at standard state. Standard state, we write 22.4. If they say room state, I mean room temperature, you write 24, but it is standard state. And remember, standard state, if the question didn't say standard state, if you see the temperature 0 degrees Celsius and the pressure at 1 atmosphere, it is standard state. So you can see the moles here is 2.24 liter. You see that this is in liter, so it's the same unit, and 22.4. So this is 0.1 mole. Okay, so how much quantity of heat that we need to only combusted 0.1 mole of propane? So you can use the ratio that if you have 1 mole of propane from QA, you need 2219 kilojoule, And if you have only 0.1 mole, you only need 221.9 kilojoule, right? Or you can use the formula, that is Q over N, right? That is 219 over 10 is 221.9 kilojoule. So the answer is option 2, that is 222, right? It just rounded up to 222. Okay, so the answer is option 2. Okay, so that is for Q5.